time. I used to look into my father's eyes. In a happy home, I was...
Hello, my name is Grant Kimple, and I'm going to show you how to solve 17.39. In this problem, it asks to describe reasonable synthesis of benzophenone from each of the following starting materials and any necessary inorganic reagents. And here's, I drew a little picture of benzophenone. Now, each part's going to have different starting molecules, and we'll have to figure out how we're going to have to attack each of these differently in order to get our end product. So, part A, you start with benzyl chloride and benzene. And a good way to synthesize benzophenone from benzyl chloride and benzene is through Friedel-Crafts acylation. And this is going to require you to use aluminum chloride, and that's going to give you your benzophenone. Now, to part B, you're going to start with benzyl alcohol, and you're also going to start with bromobenzene. And with both of these starting reagents, you're going to have to, starting products, you're going to have to change them and react them into a different compound. So the first step is to oxidize benzyl alcohol to benzaldehyde, which will happen right there. And I used PDC with dichloromethane. Then with the bromobenzene, you're going to make the Grignard reagent of bromobenzene which is phenylmagnesium bromide, and this can be just done with magnesium and diethyl ether. But once you get the Grignard reagent, you get phenylmagnesium bromide, you're going to be able to combine that with the benzaldehyde also with diethyl ether, and then the second step is going to be with hydronium. And once this is done, you're going to be able to get diphenyl methanol. And so this is going to be really useful because diphenyl methanol has that secondary alcohol which can easily be oxidized to form benzophenone. And there I used PDC again with dichloromethane. Now, C, you're going to start with bromodiphenylmethane, and what we need to do with bromodiphenylmethane is you need to undergo hydrolysis just by adding H2O, and then this is going to give you the diphenyl methanol that we had in part B up here, and you can again just oxidize that to form benzophenone. So that's how that one is done. Then D, you're starting with dimethoxydiphenylmethane, and this is going to require the acid catalyzed hydrolysis of dimethoxyphenylmethane, and that is actually it's going to yield our desired product, which is benzophenone, and as well as 2 equivalents of methanol. And there you just need to add 2 equivalents of water with the dimethoxy diphenylmethane in the presence of hydrogen ions. Part E is you're going to have 1122 tetraphenyl ethene, and the trick to the synthesis of benzophenone is by cleaving that double bond there on the ethene, and this is going to be done oxidatively through the process of ozonolysis, and just using O3, and then it's a two-step reaction, and then you're gonna the second step is going to be with water and zinc, and that is going to give you 2 equivalents actually of the benzophenone, and that's how you solve problem E. Hello, my name is Grant Kimple, and I'm going to be showing how to solve problem 18.17. And in this problem it asks to propose methods for preparing butanoic acid, which is that molecule right there, from each of the following, and it's going to give a few starting molecules, and we'll go through each one of those and what can be used to get the end compound butanoic acid. So the first one, you're going to start with 1-butanol, and a good method for converting 1-butanol to butanoic acid is by simply oxidizing that primary alcohol on 1-butanol, and this is going to give you the carboxylic acid that we need for getting butanoic acid. And here I used chromic acid, and I figured that's a really good suitable oxidizing agent for this reaction. And that one is A. Now B, you're going to start with butanol, and with butanol, this is an aldehyde, and aldehydes can be oxidized to carboxylic acid by many different oxidizing agents. Here I used on the top of the arrow, I start off with potassium dichromate, and I'm going to add that in the presence of sulfuric acid and water, and that's going to give butanoic acid as well. Now this next one is you're going to start with 1-butene, and here there's going to be 2 steps on the first part. There's for step 1, you're going to have diborane you're going to add, and you're going to try to you're going to go through the process of hydroboration oxidation, and this is going to be also done on the second step with hydrogen peroxide and hydroxide, and that's going to give you 1-butanol, like we had in our first problem, what we started with. And then from here you're going to be able to add chromic acid as just like we did in part A, and result in butanoic acid. So now D is going to be your starting molecule is 1-propanol, and this one, there's a couple of different ways that you can go about this, but all of them you're going to first start by preparing a alkyl halide from the alcohol that you're starting with. So I'll go through one of the ways, and this is what I did. I added PBr3, or you could do HBr, and that's going to give you 1-bromopropane. And from here you could have gone either two ways. You could have gone the Grignard reagent method, where you would have added magnesium and diethyl ether and then had the MGBR on there, the Grignard reagent. But I went with potassium cyanide and dimethyl sulfoxide, and this is going to give me a cyanide right there on the end. So you have the you have a nitrile that we're working with now, and from here a good way to go about getting our final product is hydrolysis of that nitrile. So after we formed it, we have to go through hydrolysis, and you can do that with just regular water and then HCl and heat, and this is going to give us butanoic acid. So that's problem D. And then E, you're starting with 2-propanol. And 2-propanol, you can start with dehydrating 2-propanol to propene, and this can be followed by the free radical addition of hydrogen bromide, and that's gonna give you 1-bromopropane. And so there we can go back and do what we did in part D right here, and add the potassium cyanide and the dimethyl sulfoxide, and go and get our nitrile, and then go through the hydrolysis step again and get butanoic acid. So the final problem, you're going to have CH3, CH2, CH. Oops, there. Sorry, I was cut off. CH3, CH2, CH, and CO2H, and there's two of those, and that's called ethyl malonic acid, actually. And this is a class of substituted malonic acids, and they're going to undergo thermal decarboxylation pretty readily, just through adding heat. And that's actually going to, just adding heat will yield butanoic acid along with carbon dioxide. So that is question 18.17. Thank you for listening.
Those days are gone. Now the